This is video number 5 of your review packet. Almost done. Problem number 8C. Okay, we have cosine of theta equals square root of 2 over 2. Well, I see that cosine is positive. Where is cosine or my x value positive? X is positive in the first and the fourth quadrants. So I'm going to ignore the second and third. Square root of 2 over 2, you could automatically know that that's your 45, 45, 90 triangle, or you could draw out your reference triangle. So square root of 2 over 2, if I was in the first quadrant, it's my x value. So this is square root of 2 over 2, and this would have to be also square root of 2 over 2, making this the 45, 45, 90 triangle. And of course my radius is 1. Now the 45 degrees would be this middle dot here, halfway through. That is my terminal side. How do I get to the 45 degrees? Well, it's easy since it's in the first quadrant. You could say it is just 45 degrees, or since we're in terms of theta, that's pi over 4. Also, we need to find that theta in the fourth quadrant. Again, it's going to be the middle dot with a reference angle of pi over 4, or 45 degrees. Now, if we went down pi over 4, if we went down 45 degrees, we would take that away from a whole rotation. So you could say 360 degrees minus 45 degrees, which would give me my theta in degrees, which is 315. Or you could do 2 pi, one full rotation, minus pi over 4, which gives me 7 pi over 4 as my angle. So let's move this out here. So pi over 4 and 7 pi over 4 are my theta, possible theta. Tangent is 0. I know that tangent is y over x. And in order to get a value of 0, I know that the top number has to be 0 and the bottom number can be any number besides 0. So that tells me that that's a 0 over 1 or 0 over anything, but I'm just going to put it over 1 because it's a whole number or a missing whole number. So if we put it over 1, that tells me that the y value is 0. Where is y 0? Well, just like b, y is 0 on the x-axis. And I kind of already gave us our point there. That's at 1, 0 and negative 1, 0. If we're on the positive x-axis and we haven't gone anywhere yet, our theta is just 0. If we go around to the negative x-axis in terms of pi, that's just 1 pi, or just pi. We could also, because I wasn't very specific in our review packet, which one I want you guys to specify. So here we could say it's also a full rotation. So all the way around, which is 2 pi. On your test, you will only be able to use one of these, so please be careful of those inequalities. If it's not equal to, that means you can't include it. For letter E, secant of theta is 2. All right, this is where it gets a little bit tricky. I know that secant of theta is the reciprocal of cosine, so it's r over x. And this is a 2 over 1. We always put it over something so we can see a fraction. Now, we are using the unit circle, I can see by this here, and the fact that I'm talking about reference triangles, you should assume that you're on the unit circle. And we say that on the unit circle, the radius is 1. So the problem is that right now my radius is 2. How do I change that 2 to be a 1? Well, you can multiply or divide the top and bottom by a certain number to get your radius to be a certain value. If I divide 2, my radius, by 2, I get a radius of 1. But if I divide the top by a number, I also have to divide the bottom by the same number. So that becomes 1 over 1 divided by 2, which is 1/2. And now we can see our r and our x value. Now where is it? Okay, this is positive and it's with my x value, so x has to be positive. Where is x positive? In the first and the fourth quadrants, just like problem C. So I'm going to ignore quadrants 2 and 3. Now this tells me that my vertical distance is my short distance of 1/2. So it's gonna look a little bit like this triangle here. And if this is 1/2, we know that this length vertically is square root of 3 over 2. So that means that opposite my y value is my reference angle, which is the large angle, 60 degrees. And this angle here is 30 degrees, but that doesn't matter to us right now. We want to focus on this 60 degrees. Okay, where is 60 degrees? Which dot? Well, 60 degrees is the furthest away from the x-axis and the closest to the y-axis, because it's closest to 90 degrees. And it's also, our unit circle is symmetric about the x-axis, so this, in the fourth quadrant, is going to be the dot closest to the y-axis. All right, now if we know that this value here is 60 degrees, we can change that to radians, which is pi over 3. And this angle here is pi over 3. But we need to know the actual angular displacement. So from 0 to this terminal angle, since it's in the first quadrant, it makes it very easy for us, just pi over 3. The fourth quadrant is a little bit more difficult. Exactly like what we did in problem C, we could say from, if we went all the way around, it would have been 360 degrees if we were in degrees. But we didn't go quite that far. We didn't go 60 of those degrees. We missed those last 60. So that gives us an angle of 300 degrees. And you could convert to radians from there. Or you can say that 2 pi is all the way around, but we missed it, subtract by pi over 3. Make your common denominators, and you get 5 pi over 3 as your angle. Or if you were paying attention in 8a, theta sub 2 is the same for both these problems, because it's the 60-degree reference angle in quadrant 4. Letter F. Cotangent. Okay, so this isn't a fraction, so I'm going to make it a fraction. I also see that cotangent is negative. What do I know about cotangent? Cotangent is x over y. So that means that I have a negative value. In order to get a negative value for a ratio, that means only one of the values can be negative between x and y. So if only one of them can be negative, and one of them has to be negative, it can't be the first quadrant because they're both positive. That will not give me a negative fraction. And it can't be the third quadrant because they're both negative. That will also give me a positive fraction. So it has to either be in the second or the fourth quadrant. Okay, now I see that it's a negative square root of 3 over 1. Well, we don't deal with just straight up square root of 3. We deal with square root of 3 over 2. Over means divide, so I'm going to change that to the square root of 3 divided by 2 by just dividing the top by 2. I can do that because if I equalize that, if I divide the bottom by 2 as well, it will still be an equivalent fraction. And now I can see that my x value is this negative square root of 3 over 2. My y value is 1/2, or the negative on the bottom. So which dot here, which reference angle will give me a horizontal distance of square root of 3 over 2 and a vertical distance of 1/2? Well, let's see. If it's in the second quadrant and I label my vertical distance as 1/2 and my horizontal distance as the negative square root of 3 over 2, opposite the 1/2 is my 30-degree angle, the one that's pointing to the origin. that is my reference angle, 30 degrees. So I know it has to be the one closest to the x-axis. If this is 30 degrees, or in radians, pi over 6, this theta, all the way over here, is almost to a whole pi, but not quite. So we would say that's pi, but go back by pi over 6, which gives me 5 pi over 6, one less than a whole. Now to do the fourth quadrant, again, it's symmetric about not just the x and y axis, but also the line y equals x. So it's going to be, again, that dot that's closest to your x-axis. This angle, again, is pi over 6, or 30 degrees. Now you're not going to take your whole you're not going to take your whole pi, but you're going to take your whole 2 pi. One full rotation, but go back pi over 6, and you get 11 pi over 6 as your theta.